Welcome from my side. So as Elisabeth introduced me, my name is Miriam Frisch, and I'm advisor at GIZ Pro Klima, which is an international program or cluster composed by various projects. And what we do is we promote green cooling, so climate friendly and energy efficient refrigeration and air conditioning devices in about 40 partner countries. And in my presentation today, I would like to highlight the environmental importance of appropriate waste management of cooling devices by linking it to the so-called ODS and HFC banks topic. So I will switch to the next slide. Yes. So to do my presentation, I will first explain what ODS and HFC banks are and why it is so important to manage them and why it is a challenge, and then also give you a small introduction to our project and what we do. So why is it so important to do an appropriate waste management of old cooling devices, or we call them RAC devices because of refrigerators and air conditioners? And why is it different to other e-waste streams? So other e-waste streams, refrigerators and air conditioners have different harmful substances. And one distinctive aspect is also their refrigerants and foam blowing agents, which are responsible for the cooling effect of these devices, but who also have an environmental effect because if they're not natural refrigerants, so hydrocarbons, ammoniac, or CO2, they contribute to the ozone depletion and or have a global warming potential. So on this slide, you can see the different refrigerant substances and their respective ozone depleting potential, so ODP, and global warming potential, GWP. And I will not go into detail, but just so you know what this slide shows. So on the left side, you can see ODP values of the substances, which are measured compared to CFC 11, which is equal to 1 and has the highest ODP. And on the right side, the GWP value is showed, which is compared to CO2, which has a factor of 1. So if we take CFC 11 as an example, we can see that it has the highest ODP with 1 and contributes approximately 5,000 times more to global warming than the equivalent amount of CO2. So all those substances which are showed on this slide have ozone depleting substances until so CFCs and CFCs, and in this case they also have global warming potential, and all HFCs they have only global warming potential. So because cooling devices use these ozone depleting substances, in the past years the excessive use of those substances has led to the accumulation of so-called ODS banks. So here we also have the official definition of ODS banks, which is defined as the total amount of substances contained in existing equipments, chemical stockpiles, foams, and other products not yet released to the atmosphere. So basically what this means, or what we want to show, is that if those ODS and banks are not managed or destroyed, they are released to the atmosphere and thereby contribute to ozone depletion and climate change. And to give you a rough estimate about the impact of these emissions, here we can see the emissions from from the ODS banks in the past 30 years. And we can see that per year, approximately 1.5 gigatons of CO2 equivalent have been released annually. So, and this compares to the yearly emissions of more than 440 coal power plants. And most of these emissions are caused at the end of life of cooling devices. So there's also a part of it which is called during the use of cooling devices, so through leakages and not best practices in the maintenance. But the major part, depending on the country, it's about up to 90%, which is released at the end of life, so during the waste management of these devices. So this is why we talk about ODS banks in the context of waste management of cooling devices. So now we saw that there are a lot of emissions caused by this inappropriate waste management, and one could ask why are they so it's approximately for the past 30 years there were the same emissions and they have not been reduced, and why are countries, or why are the emissions continuing? And basically on this slide we can see the main barriers to appropriate waste management, and one important one is regulatory. So there's actually no international agreement or convention covering ODS and HFC banks. So these substances, they are controlled for in the Montreal Protocol context, but here only production consumption is regulated and not the waste management part. So, and because of this, also many countries national legislation regarding this topic. Another barrier is informational. So this is at international level also, and national level. So at global level, there is a lack of understanding and a lack of global studies on and estimates on this topic. And national level, so many stakeholders are involved, and they in the waste management of cooling devices, and normally they like the valuable parts, copper, etc., are well known, but then for the refrigerants and foam blowing agents, the environmental effect is often not known, or at least not the extent or the importance of it. And then related to this, we also have often a lack of financial incentives to regulate recovery, collection, storage, transport, and destruction. And also related to that is technological barriers. So because so many actors are involved, a clear financial system has to be established, which could be an extended producer responsibility scheme, but still those recycling and destruction plants, they require high investment and operational costs, so one has to cover them. And another one is I already mentioned it, the complex logistical setup. So you have different actors involved in the different collecting and recycling and destruction phases. So, and considering these barriers in our ODS Banks management project, we developed a roadmap on key aspects which have to be considered and addressed to ensure an appropriate waste management of cooling devices, or ODS Banks management. Here, the link to these publications. And basically, the main publication, the Global Roadmap, is a summary of the different 4 aspects which are highlighted here in the circle. So on one hand, we have the policy framework, which explains that it is important to establish a suitable set of laws and regulation that both target both ODS and equipment containing ODS. So, for example, a venting ban or mandatory recovery of ODS for destruction, recycling, or reclamation. These are like some typical example of national regulations. And then also the financial part, which I mentioned as a barrier. Here there is some explanation on how to set up a sustainable financial mechanism. And then the collection mechanism, which I said is crucial because if so old cooling devices first have to be collected in order to ensure an appropriate waste management. And so here you have to establish a sector plan which defines the responsibilities of all different involved players. And only if those framework conditions are in place and actually enough old cooling devices are collected, then there is actually a need or investments in recycling and destruction facilities actually take profits, because if there is not enough ODS collected, then and the amounts are smaller, then you have a problem to cover the operating and the, well, also investment costs. So this is actually already showed you one of or one set of products of our ODS Banks project, and on this slide you can see some general information on the project. So we work on behalf of the German Environment Ministry within the framework of the International Climate Initiative, and we have been working since November 2013 on this topic with 5 partner countries, and our main partner institutions or also partner departments are the national ozone units in their respective ministries. But we also work with the private sector, with e-waste companies, NGOs, technology suppliers, etc. And so within the project, we have global activities where we develop studies concerning the challenges and best practices for ODS Banks management, and also promote the knowledge and the information flow on this topic. And then we also have country activities where we usually by the first component, so status quo analysis of the regulatory aspects within the countries, and then we do an inventory to how much ODS would be available for management and destruction, and then based on this we also define activities and a strategy for ODS and HSC banks management. And yeah, this would be from my side. Thank you very much for your attention. Feel free to ask questions afterwards. And I will now hand over to Rolf, who is a senior technical expert at HEAT. And we work very close with him in our project, and he's now going to present on manual dismantling of cooling devices. Rolf, the floor is yours.
Well, sorry for the delay. I don't know if it is my fault, but whatever. I'm Rolf Führen. I'm basically from HEAT company in Germany and a technical consultant for GIZ. my profession is I'm expert in refrigeration and air conditioning and electrical engineering. And I would like to hold this presentation on waste management of refrigerators and air conditioners. And we have quite a tough agenda, so I have to move a little strong forward now. In general, the agenda is introduction of the principles of waste of electrical and electronic equipment. I will call it further WTriple E management. The composition of refrigerators and air conditioners, the second point. Third, for equipment, tools, and job safety. And then fourth, refrigerant recovery, recycling, and reclaim, the triple R concept. Then we have stage 1, 2, and 3 processing of refrigerators, air conditioners disposal, and then manual dismantling of refrigerators and air conditioners for stage 1. And finally, processing of and valorization of extracted materials. So this is the overall agenda. The first point will be WTriple E is a global problem because it is rapidly growing worldwide. Globally, we have 20 to 50 million tons of WTriple E discarded per year. And generally, these appliances can contain hazardous waste, and this is a toxic waste stream. Environmental and health problem in the absence of proper waste management is a challenging problem. And WTriple E can consist of, for example, computers, television sets, etc. And of course, that's what we have to talk about, refrigeration and air conditioning equipment. So the next slide, please. And here for this presentation, we will focus on refrigerators and air conditioners. Refrigerators and air conditioners are widely distributed end-user appliances, very high sales figures. There is stock figures and high waste streams, and generally present a considerable environmental risk if not managed properly at end of life. And you see two figures, one on the left and one on the right. The left one shows the unitary AC demand globally, and what we can see is that 2/3 of the globally unitary air conditioning market is based in Asia and Southeast Asia, and the rest is distributing in Japan, Saudi Arabia, Russia, Brazil, United States, and others. On the right side, we have the unitary stock. And if you look at it, you see that there is an increase between 2020 and 2030. And that is much stronger from 2010 to 2020. Following this, the stock will grow from 650 million to nearly 1.5 billion units globally. So you can still hear me because my telephone is very silent. Okay, we'll continue. The next slide, please. Yeah, okay. End-of-life management of refrigerators and air conditioners is generally challenging because there are harmful substances and components we can see in the pictures there are capacitors from appliances and electronic PCB boards, and on the left side you can see a mercury switch which is very critical, and light bulbs, and of course more complicated than other e-waste. These appliances have refrigerants and blowing agents, and these both substances require special treatment. So Miriam already explained this chart. It shows the ozone depleting value and the climate change, the global warming potential of the different refrigerants, and we have two groups of substances where we have to concentrate on. On one side we have the refrigerants, in this case for appliances, and in terms of refrigerators and air conditioners it is CFC R12, HCFC R22, HFC 410 and R32, and for the foams CFC R11 and per example CFC 141B. Per example, for the foam blowing agent, CFC R11 was very critical because of the ozone depleting potential of 1 and the global warming potential of 4,600. CFC R12, which is still a subject for treatment, is with the ozone depleting value also of 1. A little less than CFC 11, but with a very strong global warming potential of 10,600. And I will maybe mention also 130A, which has no ozone depleting potential, but the global warming potential of 1,600 times of that from CO2. And for the foam blowing agents, CFC 141B has an ozone depleting potential of 10% of that of R11, which is a baseline substance, but the global warming potential of 700. And maybe finally, I will mention the refrigerant R22 for air conditioner, which has ozone depleting potential of 5% of that of R11, and the global warming potential of 1,810. So this chart shows really the critical values of these substances we find during end-of-life treatment of appliances in refrigeration and air conditioning. So the next slide, please. Why is the end-of-life management of other hazardous substances important? With end-of-life treatment, we find in these appliances also, for example, on first row, lead. It is found in solder for electrical components, electronic components, for example, and due to treatment released by heating up the solder. And it is very dangerous because it's heavy metal accumulates in body tissue through unprotected contact. But I think this is well known from the most engineers worldwide. Next will be cadmium. It is found in contacts, coloring of plastic casing. It will be released by burning and heat treatment. and can create brain damage and even death. And then we have mercury, mercuries in switches, for example, for freezing cases, and sensors and contacts. It is released so by heat treatment and shreddering, and dangerous because it's nerve toxin that in small doses and severe polluter of water, soil, and air. So the next slide, please. And next hazardous substance is hexavalent chromium. It is found in plating, anti-corrosion agent, and pigment in plastics, and released by melting and burning the plastic, and is dangerous because it can create or cause cancer, and only 0.6 gram of this substance swallowed by a human is deadly, so it's a very toxic substance. So we have flame retardants, the polychlorinated diphenyls, and the polychlorinated diphenyl ether. It is generally found in plastic casing, plastic wiring of cables, and printed wire boards, and generally released during end-of-life treatment by melting, burning the plastic, and shreddering, and as other substances here shown in this chart, causes cancer by contact. So the next slide will indicate the regulatory framework for successful management of ozone-depleting substances and F-gases. And this regulatory framework is founded on two columns. And for disposal of refrigerators and air conditioners, we have on one the WTriple E regulation, which is very important in Europe and tackles all these technical standards for the professional disposal of all these appliances. And one column is the ODS regulation and the F-gas regulation we have in our countries. So the advantages of end-of-life treatment is the avoidance of negative environmental impacts with the protection of the ozone layer, the protection of the climate system, preventing toxic substances to enter our ecosystem, and saving raw materials. Economic benefits from precious material winning back from this end-of-life management system. The second point now for the agenda is the composition of refrigerators and air conditioners. And we start with the average material composition of refrigerators in Europe. And you can see very easy that the dominant parts are steel, compressor, which is separately shown here, which has also steel and copper. And then we have plastic, PUR, and 43% of the overall material amount is steel, and 23% is copper. Plastic without PUR are 16%, PUR is 10%, and non-iron fraction for the casing is 5%. Well, summary of hazardous substances is, as I already mentioned, and I hope that it did not forget something. Most important critical refrigerants, we have R12, R22, R410A, and R32, and ammonia solution containing chromium-6. Most important critical blowing agents are CFC11 and HCFC 141B. Next in the row on hazardous substances is mercury, then printed circuit boards components with lead, cadmium, and hexavalent chromium, and flame retardants. And then we have in the capacitors, we have PCB and PBB and PBDE in plastic and flame retardants. Well, then we are again on our agenda, and we come to our point 3, equipment, tools, and job safety. And for the job safety, very basically important issues are the protection of workers, so occupational health and safety, gloves, shoes, working trousers, safety gloves, dust mask are very important. I included here the figure class P3, fine dust, mist, and metal fume protection is very important, so just the regular mask will not be helpful. Then we have earplugs and ear masks for personal protection. Necessary equipment of WTriple E management companies is generally electrical working tools, for example, side cutter, but also drivers and whatever. Hand tool is a scraper as well. Spanners, a range of spanners, a hammer for heavy works, and on the right side down I put another hand tool. It's a crowbar with flat ends. It's very helpful for the stripping of foam, because I think it's very important to mention at that point that the goal is to maintain with foam stripping large pieces, as large as possible, because with treatment you will release also already the foaming agent, so it is very important that you receive large pieces by foam stripping. Another tool is electrical angel grinder, a drilling machine for compressor treatment. If we not recovered oil and refrigerant at the same time from the refrigerant circuit, we have to separately treat the compressor. The hydraulic shear will be very helpful for a quick disassembling of the metallic parts, and cordless screwdriver, of course. Next slide would show equipment for WTriple E management companies for dust collection system to prevent small particles from entering the lungs. Filter must effectively capture particles of at least 5 micron small, and this equipment is basically a working table where you put the appliance on, and the working table is connected to a ventilation system with dust bag and filtration system. Then we have necessary equipment also as a stationary recovery system. Here on the left picture, the separating refrigerant oil mix is a receiving tank oil separator, which can look very different from the chosen system on industrial scale. Here is an oil separator and refrigerant separator working with electrical heaters, but this equipment is also available for other oil separating equipment. Then we have pressure vessels for the receiving refrigerant and oil container for the lubricants from compressors. Next is to show necessary equipment for management companies for different types of container used for transport and separation. It is maybe important for the transport way on road. You need containers and vehicles. And you need a lot of smaller containers for the separation of the different valuable parts of the appliances, like cables on the left side, very, very useful because there's a lot of copper in. And on the other side, you can see a small container with the refrigerant circuit components like filter dryer and copper tubes, aluminium, and so on. So it is important to execute sorting of glass, sorting hazardous components in an appropriate manner. For example, the capacitors, that they will be stored in containers which are useful for this purpose, and storing of the crushed pieces of PUR foam. Our agenda again, well, we have now more insight for the refrigerant recovery, recycling, and reclaim, the RRR concept. First of all, definitions of that. What is the meaning of refrigerant recovery, recycling, and reclamation, whether in the field or stationary in a workshop or in a WTriple E waste processing facility. So refrigerant recovery is simply to remove the refrigerant in any condition from a system and store it in an external container without treatment. Then the term recycling is to reduce contaminants in used refrigerant by separating oil, removing non-condensable gases such as air, using devices such as filter dryers to reduce moisture, acidity, and particulate matter. And then the term reclamation is to process used refrigerant to new product specification and verify by chemical analysis of the refrigerant that the product specification has been met. So this is the meaning of the RRR concept. So next is a presentation of tools and equipment used in the field for refrigerant recovery and recycling. We have a recovery unit on the top left side, which is often used in many Article 5 countries for the purpose of refrigerant recovery. Maybe there are a lot of recovery hand pumps, and this recovery hand pump is very unique for me, because for people in the field that have to recover refrigerant from refrigerators and air conditioner containing flammable gases, this hand recovery pump is very useful because it doesn't provide any source of ignition. So that's why I mentioned that. Then we have a recovery bag. It is an old tool. I will not say that it is still very valuable, but it is to be found. Very important is a pursing plier to maintain the access to the refrigeration or air conditioning refrigerant circuit, to be able to suck off the refrigerant from the system. It is important to have a weighting scale down on the left side for the measuring of refrigerant charge amount of the recovery cylinder, to know how many refrigerant is actually recovered from a system, and very important, not to overcharge the refrigerant recovery cylinder, which is very dangerous for the people working with this equipment. Then on the next slide, I included a picture of, let's say, industrial stage 1 recovery system, which will be also possible for the connection with stage 1 equipment and manual foam stripping and degassing and recycling system. And basically this system is a refrigerant system, the refrigerant degassing system, together with oil and refrigerant at working station. It is basically, also a refrigeration system. It is necessary to have a deep cooling chamber for temperatures down to approximately minus 35 degrees Celsius for the reduction or for the removing of the non-condensable gases from the received refrigerant. And on the other hand, it is a pneumatic system for the refrigerant and oil recovery system. So the next slide will show some recycling equipment for field use and for workshop use also. On the first row above, there is a small recycling unit for service technician in the field. They can remove and capture oil, humidity, and particle matter. The same equipment on the top on the right side is used for recovery unit connection as well. It's an oil separator, the filter dryer, and the strainer, and the red big one on the left, and the bows on the bottom row. These are recycling units. The one on the right side is also certified for the work with a refrigerant and to treat it to international standards such as RE 700 or 740. The next slide is a reclamation unit. It can reclaim refrigerant to specification. I already mentioned RE 700, which is an American standard. It described the refrigerant condition as a virgin substance. And RE 740 is generally used for the specification of recovery, recycling, and reclamation equipment. This machine, for example, can continuously operate for batches or for small amounts of refrigerants. And later on, if the refrigerant and also the lubricant, the oil, is captured, there should be verification of the reclaim process by using gas chromatography, moisture test, for example, Carl Fischer titration, and finally acid, oil, and particles testing in laboratory condition. So next is our agenda. We have now the description of stage 1, stage 2, and stage 3 processing for recovery for refrigeration and air conditioning equipment. The stage 1 is generally describing the removal of loose parts, extraction of refrigerant and oil, separating of oil from refrigerant, and also separating refrigerant from oil, because for the WTriple E concept in Europe, the oil received by end-of-life treatment should be with a concentration of less than 0.2% of refrigerant to use it as a waste oil process. Removal of the compressor, including attached components, draining of the compressor from oil, and removal of condensing unit if we have appliances in manual disassembling process. This presentation and the guideline on manual dismantling focus generally on stage 1, but I think I already mentioned that at the beginning. The next slide is an presentation of extraction of refrigerant and oil machine in more industrial scale. It can be operated by tools like piercing, but it can be also operated by so-called drill head. The drill head has an advantage. It can suck refrigerant and lubricant from the appliance in one course. That means at the same time. And the recovery process is less than 1 minute. The recovery of refrigerant from appliance by the use of a piercing plier is not more complicated, but more time consuming. And it is really not very useful for recovering of oil using this piercing plier on the top left side of the picture. So we have situation 1, use of thrusting plier, or situation 2, use of a drill head. But this is already a professional equipment, what you can see on the right side on the presentations. Well, stage 2 is the crushing process in an encapsulated system with a recovery of the blowing agent. Encapsulated system is very important to mention because during the crushing process, the blowing agent will escape and it has to be recovered. Recover the blowing agent must be stored in adequate cylinder or drums, but before that it must be liquefied again. This happens also by connected refrigeration system to the stage 2 unit. The stage 2 unit and system is relatively expensive with investment costs and can create costs between 2 and 4 million euros. Then we have stage 3, the final destruction of ozone-depleting substances that took place with stage 2. The destruction of liquefied or gaseous refrigerant and blowing agent by thermal or catalytic treatment. Destruction. This is stage 3. With the next slide, we will have a visual diagram of the stages. That what we presented here in this presentation is generally the stage 1, and it is a gray process on top. It is the processing of refrigerators and air conditioners, extract refrigerant, manual dismantling, and then further dismantling, including foam stripping. And the red area is stage 2 and stage 2 only specification. It is the pre-crushing process of the appliances. Again, the processing of the materials by a crushing machine and removing from that crushed particles the liquefaction and absorption of the blowing agent and automatic material separation of polyurethane, polystyrol, steel, aluminum, and copper. This is stage 2. And on the next stage, no, stage 3 we do not have, but I already mentioned the stage 3 is destruction of materials and substances. So we should have now the agenda again. The manual dismantling of refrigerators and air conditioners, stage 1, more in detail. It is manual dismantling is not the state-of-the-art technology, but if carried out in an appropriate way, it can lead to a significant avoidance of emission and therefore a significant mitigation potential. And I want to mention at that point again that the foam stripping is one crucial aspect, and as I already said, it should be the goal to receive large pieces of foam and to treat these large pieces for final destruction then. Benefits of the manual dismantling is employment opportunities, and there with income also for population segments with low level of education. It is, let's say, very easy to train these people how to carry out end-of-life treatment of appliances and equipment. High degree of homogeneous sorted plastic and metals, which are precious goods, commodities on the recycling market. Less investment costs for preparation techniques and sorting procedures. Less investment costs, I think you can imagine that the equipment for manual dismantling will be a percentage of the total overall investment scale for an industrial processing equipment. Well, the next slide will show the course of dismantling of refrigerators. First, remove of all loose parts. Second, remove cables. Third, identify and extract switches. Fourth, extract the refrigerant at the lowest point and separate oil and the refrigerant using appropriate equipment. Then cut all visible polluting parts. Then identify and extract capacitor. Remove the compressor. Remove the heat exchanger. And then foam stripping. And finally, balancing, record keeping of the raw materials received. This is the assembling of refrigerators, disassembling or dismantling of air conditioners, more or less comparable. First, we start with out plastic paneling removal, and then we go to the circuit board. Third, extract the refrigerant at the lowest point and separate the oil and the refrigerant using appropriate equipment. At the lowest point means with the process you have to place the equipment in a way that the compressor shows or is facing downside, and the refrigerant and in specific the oil will accumulate at the compressor bottom, and then you can access for refrigerant and for the lubricant. Then we remove the compressor, we cut all visible polluting parts, remove the heat exchanger, extract the fan and the E-motor, remove all visible cables, identify and extract the capacitor, remove transformer, and then again record keeping and balancing of the amounts of raw materials received. So now we come to the last step. It is processing and valorization of extracted materials. With the process, further separation of extracted components takes place. Greatest advantage of manual dismantling is high degrees to which plastic and materials can be separated. So finally you will maintain a higher selling price of the raw materials again. Distinguishing metals and plastic and steel, aluminium and copper, the most valuable materials from the system, and also considerable polystyrene, propylene, and other materials. generally to say is that metals are easier to distinguish than plastic. Some components have already a label on the materials, for example, on plastic materials from the housing and doors and so on. Metal parts can be easily distinguished with magnets or the tools or visible. Use special detectors for the identification of plastic, which can be X-ray fluorescence or maybe near-infrared wavelength spectrometry, NER, or sliding spark spectrometer, ODS. Then the final disposal, the next slide. The following extracted components are subject for final disposal. This will be the capacitors, ammonia solution, which is containing the chromium-6, used usually in small refrigeration appliances like minibars or so on. And then CFCs or other critical refrigerants and blowing agents. And the following table provides an overview of the different recycling options for materials that are recovered during manual dismantling and refrigerators and air conditioners. So we have on the left side, the components, on the right side, the recycling options. I will just mention the most important parts. Aluminium sheets by smelting, iron by smelting, PS granulate by mechanical recycling, compressors, smelting and separation of components, or probably manual dismantling of a compressor and receiving metals and copper parts out of the hermetic compressor. Cables and without plugs are more than cables with plug. So you will receive more money if you have only the cable, and so for that reason you should disconnect the plug before recycling of the material. Next slide is aluminium cast is also a recycling option for smelting. Stainless steel by smelting, capacitors must be finally disposed, or first separation and then smelting, because capacitors can have a large amount of PCB. And then we have the mercury switches, which has to be treated with a lot of care. It's necessary to separately recover the mercury in special plants. And then the rest of the switches are in specific glass. For the plastic components, we have mechanical recycling, feedstock recycling, and energy recovery. The refrigerant goes for final disposal, or theoretically for reclamation if it was recovered by separation of the different types of refrigerant. Ammonia final disposal will be the option, and for polyurethane will be final disposal when PUR contains harmful blowing agent. This gas PUR to be used as an oil binding material and crush it, degas PUR to be used in cement kilns and co-firing, so burning. So the next slide is the value of extracted components. The most valuable components are aluminium, copper, heat exchangers, and cables without plugs. Higher degree of dismantling results in higher returns. Dismantled compressor, if possible, because higher price are achieved when selling the single component separate, so the iron and the copper as well. Probably sorted plastic achieve higher prices than mixed plastic. So as I mentioned before, it is possible to identify a lot of materials from refrigerators by looking for the specific marking of the plastic components, then separating to receive higher prices. Price balancing in generally is positive for both refrigerators and air conditioners, and the revenue is between 5 to 15 euro per appliance. End of life treatment. More information on manual dismantling of refrigeration and air conditioning appliances can be obtained with our public management and destruction of existing ozone depleting substances banks. And this is on the homepage, on the webpage from GIZ